Let's say I gave you 3 points, and when you plotted them, you were able to connect them with a smooth curve that graphed a quadratic function that made the shape of a parabola. The question I have is, would you be able to come up with the equation of that parabola given the 3 points? The answer is yes, and when you find that equation, what you are accomplishing is this idea called curve fitting. All right, so the standard form of a quadratic equation is y equals ax squared plus bx plus c. And so our job is to take the following xy pairs, 1, 3, 3, 5, and 4, 9, and put them into this equation one at a time and solve for a, b, and c. And so the process of curve fitting involves a system of equations, and you remember that from algebra, I hope. But this time there will be 3 equations. So this might be something brand new to you. If not, I hope you do remember it. All right, so here's what we're going to do is one at a time we're going to put these ordered pairs in for the x and y, and then we'll combine them using some substitution and elimination and solve for a, b, and c. All right, so here is the first equation using the ordered pair 1, 3. So here's y equals a times 1 squared plus b times 1 plus c. The next one, 3, 5, will be 5 equals a times 3 squared plus b times 3 plus c. And then the last one, 4, 9, is a times 4 squared plus b times 4 plus c. All right, so system of equation involving 3 equations to solve for 3 variables. So first thing we want to do is we want to clean them up. So I'm going to go ahead and rewrite the first one as 3 equals a plus b plus c. The second one, 5 equals 9a plus 3b plus c. And the last one, 9 equals 16a plus 4b plus c. Okay, so our goal here is to get the variables to drop out. And so I think the easiest way, and there's more than one way to do this, but I think the easiest way recognizes that all 3 of them, the c, the coefficient of the c is 1. And so those will be the easiest ones to get rid of first. So the first thing I'm going to do is combine the first 2 equations only. And by subtracting, I'm going to make the c's disappear. So I'm going to look at 3 equals a plus b plus c, and 5 equals 9a plus 3b plus c, and I'm going to put them together in such a way that I subtract. Okay? If you want to take the time to change all of the terms to the opposite and add, that's an acceptable way to do it, but I think that you'll be okay by subtracting. So here's what I've got. 3 minus 5 is negative 2. 1a minus 9a is negative 8a, and 1b minus 3b is negative 2b. Okay, so I'm going to hold on to that and go back and put the second and third equations together by subtracting them. 9a plus 3b plus c, and 9 equals 16a plus 4b plus c. So again, I'm going to subtract, and this time I get negative 4 equals negative 7a minus b. All right, so now I'm going to just bring this one over here, line it up. Negative 4 equals negative 7a minus b. And I hope that you recognize this as now simply equation with two equations with 2 variables, and we need to combine them so that either the a or the b drops out. And I hope that you can recognize that if you multiply through the second equation by 2, then, let's go ahead and make it a negative 2. Then the negative 2b and the positive 2b will cancel each other out. So multiplying through that one by negative 2, I get 8 equals 14 plus 2b. Right underneath that, I'm going to write negative 2 equals negative 8a minus 2b. That's just simply copying that first one down. And then, sure enough, these are going to cancel. This time I'm adding the 2 equations together, and I get 6 equals 6a, and a turns out to be 1. Okay? Once you get the first variable, then it's just a process of substituting back into different forms of the equation and finding the other variables. All right, so I can put a either in, let's see, I can put it in here or I can put it in there. but I want to make sure I put it into the equation that has only two variables. If I put it back in here or here or here, I'll still have two variables left. So let's go ahead and look at the first equation, which is negative 2 equals negative 8 times 1 minus 2b. When I bring the negative 8 over, I get 6 equals negative 2b, and b turns out to be negative 3. So I'm almost done. I've got two of the variables. I just need to substitute the a and the b, and it doesn't matter. I can actually use any one of those three equations. So I'm going to go to the easiest one, the one on the top, which is 3 equals a plus b plus c. So 3 equals, here's a, here's b, and here's c. So when I move the negative 2 over, I get c equals 5. So to answer the question, I put it together. I say that if I were to graph the equation y equals 1x squared minus 3x plus 5, it would go through the ordered pairs 1, 3, 3, 5, and 4, 9. Okay, so that's today's lesson. We're going to practice this a lot in class until you get really comfortable with it. Great, thanks for listening.